how the network and the industry is being disrupted with disaggregation. I'll just go through them quickly. The first one is AT&T. Several years ago, they bought a company called Viata from Brocade. And Viata make a third-party network operating system. AT&T wrote a white paper. They renamed Viata Danos. And they gave Danos to the Linux Foundation and said, it is here for all to use. So today, you can go and buy yourself a white box, switch, and stick Danos on it, and Bob's your uncle, and everyone will be happy, and away you go. So they are big on it. They have part of their network refresh is to put out 60,000 white boxes at cell sites around the world. This is all well known. And stick Danos on it. The second one, Deutsche Telekom, working with a company called RT Brick, a third-party operating system company, to develop a product that will suit their Access 4.0 network infrastructure. RT Brick is a bunch of Juniper and Cisco guys who have come together and decided to make a modular operating system. Every RFP that comes out from these guys says you've got to run RT Brick on your white box or on your hardware. Telstra in Australia invested $43 million in Cumulus. Cumulus is probably the most popular third-party operating system. And obviously they've come to Cisco and said, we've got this software, we want it to run on your hardware, please. I'm not saying we're doing this stuff, but these things are happening. The last one is Reliance. Reliance in India is the largest 4G greenfields network in the world, amazingly complex. And they bought a company called Radisys to write software, third-party software for them, and network operating systems. So it's real and it's happening. So I've mentioned white box a few times. What is it? A white box, there's nothing to it. It's like a pizza-sized single rack unit box, and it's got a whole bunch of open hardware features in it. It's got a board management controller. It's got the microserver that runs all the routing tables and things like that, power supply, and the most important thing is that switching ASIC. And it's got some environmentals and a few other bits and pieces. It's all off the shelf. Generally, they're Linux-based. They're white boxes. They don't have any operating system besides the platform operating system. And they're very cheap. And off you go, knock yourself out, go and buy a couple. What do you get in it when you buy one is, well, the hardware and all those other bits I talk about, and a little bit of boot software called ONI, Open Network Installation Environment. Because if you write a third-party operating system, it's got to get into the box somehow. And ONI is the boot procedure that does that. So every third-party operating system in the world that runs on a white box has to be ONI compatible. It has to be in an ONI image that gets booted into the box. And this is where we start talking about standardization. Everything is, open and standard. There's not much else in the box. That's it. Your responsibility to go and find the operating system. So the white boxes are generally, the majority of them use Broadcom chipsets. And here I have tried to make a simple slide, which I failed badly on. I have a complex looking slide, which shows you 3 chipsets of the Broadcom family, the Trident, the Tomahawk, and the Qumran. They all have different functionalities, but essentially nearly every white box in the world, that's all the orange labels there, the companies, runs a Broadcom chipset. So, that's the white box, that's the hardware. Nothing to it really. The next question is, well, what about the software? What's so special about it? How do you actually disaggregate? A typical integrated router looks like this. You've really got a monolithic piece of code. It sits on a piece of hardware, and all the abstraction happens within this monolithic piece of code, this integrated code. And the only API you have is really the management functions to get into the box to look at the MIBs and things like that. That's what we generally do today. So what happened a few years ago, the value proposition is what I've already covered, where you've got a rich feature set, it's all pre-integrated, it's tested and things like that. And the disadvantage of an integrated system is it's integrated. You can't separate the features that you want. It's a proprietary solution, etc., and so on and so forth. So initially what happened in Cisco is that we were looking at the disruption that disaggregation was bringing, and we thought, well, okay, we better try and start opening up the operating system at different APIs. And the first thing we did was we opened up something called a services adaptation layer, and that allowed you to manipulate the data structures of the routing table. Why would you want to do that? Sometimes you want to change the paths and the routing tables in a way using a metric that is not available in the routing table itself or the network. This may be something like cost of electricity. It might be weather patterns, all sorts of other interesting things that you would decide as a business is important to create a network based on your metrics, not on what Cisco decides is the best thing. And that's what this SL API does. That was the first foray into disaggregation from Cisco. But now we are bringing out disaggregated XR based on the specifications that have come out from the world of disaggregation, where there's this complete separation between hardware and software. And you end up with, if I can point here, the hardware is separate, running this ONI, Open Network Installation Environment software. Then you've got this base operating system that abstracts the hardware and provides a nice API to the network operating systems that run above it. And really important is this switching ASIC, because you can get switching ASICs from Broadcom and Mellanox and a whole bunch of other people. Excuse me. But they have to be standardized. And so what that is done by this SDK, this hardware abstraction API, where you can manipulate the forwarding tables, but you do it in a standardized way regardless of which ASIC you use. So every white box comes out with a platform software as well that is compiled into the network operating system that allows you to talk to the ASIC. And to summarize it, you end up with three main components of a disaggregated system: the white box hardware, the platform operating system that abstracts everything, and then the network operating system that sits on top. Yeah? Any questions about that? We've got plenty of time, and we'll be finished in 30 minutes, so you'll have your half an hour back. The last one is this, on this particular section. We have programmability in the world of compute, where we can program the chips. You've got Java, OpenCL for graphics, MATLAB, and TensorFlow. These are all languages which manipulate the ASICs that do particular things. Now there's a language called P4. It's a really interesting, very, very simple language which allows you to manipulate the switching ASIC. You can invent your own protocol. What P4 does is it allows you to create pipelines in the chipsets. You can look for headers, bits. You don't need to use IP. It can be anything. And you can switch at ASIC speeds. And p4.org is the website where you can go and look at the language and download the actual SDK. Very interesting. And Google and Facebook and those guys actually use this sort of language, maybe not this exact language, but similar, to manipulate their ASICs when they invent their own protocols to meet their needs. And the world of disaggregation, as I said, is providing APIs at every level, including right down to the ASIC. So now you have knocked yourself out. You can configure anything and manipulate anything you want in any way you want. This is the whole idea. Network operating systems. Well, what's out there? There's heaps of them. They're all over the place. Cumulus is probably one of the more popular ones. The interesting thing about Cumulus is it is a proprietary integrated network operating system, just like Cisco. It does not run on open APIs. You've got to compile everything into it and then run it on the hardware. So it's not necessarily open, but it's the most popular one. RT-Brick is coming up a little bit. SnapRoute is getting there. Danos, of course. And XR. As I said, there are other presentations on how XR is disaggregated. It will run on third-party white boxes. And it is today doing that. So there are other presentations that will explain that. So we have 3 models for software only, which is what we call disag in our world. So the first one is we have disaggregated the software from our hardware, but it still runs on our hardware and still full stack. That's what you see here on the right-hand side. But we now charge, or we will charge separately for upgrades. We give value to the software. In the past, it has been an integrated system where you couldn't tell the difference between the software and the hardware. Now we give value to the software where we now can do recurring revenue models. And that's what Cisco is moving towards, is this world of software rather than hardware. That's a pretty obvious thing to do. The next part was where we are right today in the middle. Software-only model where we can sell XR software disaggregated that has been bundled with the platform operating system, and we will run it on certain bits of hardware. Where we're moving to is the third part, where you provide the hardware and the platform, and we will just provide XR as an application on Linux. And next to it, you can run other applications which manipulate what XR does through APIs. This is coming back to where I was talking about, I want to base my routing metrics on the weather, or on a data center that's failed, or it's costing the electricity too much at that data center, I want to send everything to this data center. So that's what these applications will be able to do. The approach we took with XR, it's all about modularity, programmability, conformability, they say, to run on Linux. There's too much on this slide, in my opinion, to explain, but the best way to say it is, why do we have to write stuff in our operating system that already exists somewhere else? And the good example is, if you're running XR on top of Linux, Linux comes with terminal emulators, SSH, syslog, security. Well, we'll take all of that stuff out of XR and just rely on what's below us. So it makes XR smaller, more simple, get rid of a lot of features. What does it do? It opens up the world of larger footprint for security issues. The advantage of an integrated system is no one has the code for XR. No one knows what's going on, so it's a little bit more secure. In this world, everyone knows what Linux is doing, so the attack vectors become far broader in a disaggregated system, which is good for the vendors because then we can sell you more security type stuff. I'm just telling you what's happening here. I'm not biased on either way. We're looking at what the disruption is, and we will, if the customers want disaggregation, then we will give you disaggregation. But you have to go in with your eyes open. So XR on a white box is really, at the moment, as I said in the previous slide, you've got the hardware, you've got a network operating system with the platform operating system compiled into it. As I said, the platform operating system abstracts the hardware. Now, if we had XR for 5 different white boxes, there would be 5 different orange bits here that would abstract the different characteristics using the open APIs. Because if you have 5 different boxes, the ASICs may be different. And so the SDK and what we call the switch abstraction interface, which controls the ASIC, is different. But the API is the same. But you have to compile that all into this product here. And then on top, you've got all the management stuff. Now, the next version of XR, Disaggregating, will take that yellow bit out and stick it underneath, and all you get is an application. Makes it a lot simpler. So some observations. You know, over all the years, what have we noticed with disaggregation? Well, the first thing is we noticed that most of the disaggregation, all of the disaggregation happens at the edge. And at the edge, you have very simple boxes. You have simple boxes, single MPUs, maybe a double MPU, but it's simplified. It's easy to disaggregate. When you move over to the right-hand side where you've got multi-chassis systems, it's really complex. You cannot disaggregate a system like that easily. You don't want to disaggregate central in the core. You want to disaggregate at the edge. No one is disaggregating in the middle. It's far too complex. And so the more line cards, intelligent line cards, backplanes, etc., the harder it is to disaggregate. So we know that disaggregation happens on this section here. And we're seeing that today. We're also seeing it, obviously, in a very simple network diagram here. The disaggregation is very applicable at the access, at the branch, at the top of rack, to the aggregation point where you might have edge compute, and also, here, the top of rack and at the spine in a data center. Now, I haven't mentioned a particular chip from Broadcom called Jericho. Are you familiar with the ASIC called Jericho? So Jericho is an ASIC which is used predominantly in data center switches. Now, what's so special about this thing? It's called Jericho because it breaks down the walls between WANs and data centers. What's the big deal there? Well, in a data center, you don't have any requirement really for buffering because all the speeds are the same. Everything's optically connected. It's switching very quickly. But as soon as you go out to a WAN, you need to buffer because you don't have the same speeds. To buffer, you usually use a different chipset. But what Jericho does is it can be a router and a switch at the same time because it has deep packet buffers inside it. And so this same chip, it runs a little bit slower than the other chips, but it can be a router or a switch. And so if you can do that, you can start to collapse in the data center all the routing functions and the switching functions so that the central spine switch can also be an edge router that goes out to the internet because it can buffer. It's a small but important point, and it allows for disaggregation as well. And this is where the web players are really interested and are doing things by collapse. It's called a collapsed spine or a universal spine where it does everything. And all of this stuff disappears into one God box. Everyone wants a piece of the disag pie. I can't tell you how many RFPs come out and there is some aspect of disaggregation at every part of the internet edge, the cloud, metro networks in the data center. They're constantly coming out, and they essentially say, we want you, Cisco, to quote on hardware, don't tell us about XR, don't tell us about XE. We just want the hardware. This is a problem for us, obviously. Or they'll say, we want the XR, but we want it run on this box here. And you think, well, why would you want to do that? But they do have their reasons, but we're seeing this. And so you cannot ignore the fact that this is happening. Which brings us to the obvious problem, is how do you support this sort of thing? Because you've got to look at the serviceability aspects of having a disaggregated white box with third-party operating system, whether it be us or someone else. Who do you point the finger at when something goes wrong? Whose responsibility is it to diagnose the issues? How far down into the stack do you go when you're looking at problems? Now, we have a whole bunch of TAC guys that can spend a lot of time deep in the bowels of the ASIC looking at buffers and things like that, looking at ribs and fibs and all the label stuff that happens. And if you have a third-party white box, it becomes a little bit of an issue as to, well, how far do we go? So we've seen this, and we've seen customers come to us and say, we'd like you to support this combination. And sometimes that combination doesn't have any of our gear in it, which is, an interesting situation to be in. So there are a bunch of support scenarios. The first one is just stay where you are and we'll support everything, just like we do today. Remember the old days? We'll just keep the good old days going. Or you have this world of disaggregation where the customer says, I can handle it. I'll tell you whether it's your problem, Mr. Hardware, or your problem, Mr. Software. And then you have some sort of agreement between these two vendors to talk to each other and sort it out. But the customer ultimately is responsible. Remember that dial I showed you? This is the dial going all the way to the right, saying the customer takes responsibility for the whole thing. Or where we're actually seeing it happening is this one here, where the customer who wants to disaggregate a network says to a vendor like Cisco, well, we'll give you responsibility and you go handle the two parts and figure it out. And obviously that's going to cost more. And that's the one we see. Now, you might all be thinking, why the hell would you want to disaggregate? Well, there's still financial benefit at scale to still do it, even if it costs more to support it. But this is the model that we're seeing people want. The ecosystem of disaggregation is healthy. Like the internet, everyone can contribute to the internet, right? The internet is a free spirit. It's like those hipsters. They just hang around and we create RFCs and we create new protocols and we solve problems that didn't need solving, or we create new problems that need solving. But the internet is just a big bubble that just bubbles away and we fix things. Well, disaggregation is the same, where you've got all these players all doing different things and they all work somehow in unison to get it working and standardized. And so these bubbles here are, you've got at the top, I can't tell you how long it took me to make this diagram look like that, because it's very symmetrical. It took me like a day to look at how we would get all these things working, and lo and behold, it all became beautiful and it started to make sense. So we've got the silicon vendors over on the top left-hand side who are providing the chipsets. And then you've got the white box vendors over here that are building the hardware, that are using the silicon vendors' ASICs. You've got the NOS vendors, the software guys down here, creating the software. You've got the Open Compute and Linux Foundation that are providing the standards, the standardized APIs and things like that. So all of these guys work together in unison to create what we call a disaggregated system. It is a little bit complicated, but it seems to be getting together. The Open Compute Project are responsible for defining a whole bunch of standards, APIs. The Linux Foundation provides DANOS, that third-party operating system. What the Open Compute Project has done is they developed ONI. They're the ones that said, well, no, obviously it became, the first problem was, well, how the hell do we get an operating system into this box? So they developed ONI, the Open Network Installation Environment, and said all white boxes must have ONI. All network operating systems must have an ONI image. Everyone's happy, thank you very much. The next thing they did was they noticed there's so many forwarding ASICs, there has to be a standardized way to talk to the ASIC. So what happened was an SDK concept was created where every ASIC manufacturer has to provide a software development kit for their ASIC that provides the next layer here called the SAI. It should be called Switch Abstraction Interface. That's really important. It's the hardware abstraction for the ASIC. So the Open Compute Project defined the SAI. We call it the network forwarding abstraction layer in our terminology, but it basically does the same as the SAI. So every network operating system, third-party network operating system, understands the API SAI and understands the calls it needs to do to actually get the packet, the frame, to forward through the ASIC. And that's what the Open Compute Foundation did. So they've created a whole bunch of standard APIs. There are heaps of players in the disag market today, from hardware to the SDKs to the abstraction layer to the applications and the network operating systems. This is a crowded market, and I reckon in the next 12 to 18 months, obviously there'll be aggregation of a lot of these people. I don't think many of them are making, the smaller players aren't making a great deal of money. What is really good about Disag is this, is it opens up a new world for programmers and software developers, where you can start developing apps for networks, not apps for your phone, that do certain things, do certain metrics, base routing on certain metrics, etc. And again, because you can access functionality at every layer, and there's APIs at every layer, you can provide apps at every layer. So you might invent your own protocol and use P4 to configure that ASIC and sell that brilliant protocol that you've invented for a data center, because you have access to the white box hardware, because they all understand P4. So it opens up a new world. Write your own operating system. Maybe you just want to write one particular feature, function, behavior for a switch, and that's all it does, and nothing else. So it's less likely to crash. But you need a lot of knowledge, and it's really only the big players that are in this market, and I say big players, I mean Google, who have guys that are IT people as well as software people as well as hardware people. So, in summary, what's our view, right? Are we freaking out? What's the story? Is it terrible? No, it's not. We will always support any trends that we see, but we go in with eyes open and we make sure your eyes are open to it as well. The view is this: we think that disaggregating is a new value proposition. If you disaggregate the software from the hardware, we can charge for the value the software brings. And it's not just us, it's all the vendors will do that. Arista, Juniper, etc. So it's good for us in that we can provide value and distinction between the two bits now because they're not integrated. We know it's not just the web players. We're seeing this trend happening across large enterprises, and a good example is a particular financial institution who wants to work on their own protocol to deliver financial stock information in a timely manner at the same time to all their brokers so that one doesn't have an advantage over the other. And that requires deep protocol skills to do something like that. In other words, they want to take responsibility for how that information gets to the broker, not running over our operating system. Accessing new addressable markets, all of a sudden we can just sell the software rather than the hardware. That's very good for us. But the really important one is that our strength is there is no, I'm sounding like a salesman here, and I'm not, I'm an engineer, but there is no other company that has the reach of Cisco when it comes to support. In every country, 170 countries, there is a tax support. And if you run a disaggregated system worldwide, who's going to support it? There's only one company that actually has the breadth to do that, and that's us. And we're seeing this with certain large customers who are putting disag systems out and saying, in Botswana, who's going to support it? Cisco, can you support it? We're seeing this behavior now. And they're driven because the costs of the boxes are so low, it's still in their interest to pay us more for support than it is for them to pay more for the hardware. So in summary, it's an absolute reality that disaggregation on scale is happening, and there's a lot of interest in it. Something that I didn't really clarify to you was that disaggregation is all about the network world following the compute world from 20 years ago. You know how you could buy the funkiest piece of hardware and stick an operating system on top. You could have Ubuntu, Linux, Windows. And that's what we used to, in fact, gamers do that today, and you tweak your hardware and you change a little bit of the software. Well, this aggregation is all about following that compute model. And that's where we are at the moment. We're seeing, the separation of that hardware and software and being able to tweak everything. Gives you increased flexibility in options. Increased flexibility, decreased number of features because you just want what you require, but more responsibility upon you to run the thing. And programmability, probably the killer app of disaggregation, the ability to be able to control every aspect of that bit of hardware and try and remove human intervention. That's the whole idea. Try and automate everything so that you don't have finger-defined networks ruining your uptime. So, short and sweet, easy for the morning. We've done it in less than an hour, and I spoke slowly too. Usually I speak fast. But with the accent, I'm not sure if you guys would be able to follow. But if you do have questions, you can use WebEx Teams. And obviously, I give you guys a 5 for attending. So if you want to fill out the survey, go ahead. Do you have any questions, please? Yeah, sure, first. If you want to experiment with this stuff, where would you go? Yeah. So if you want to experiment with this stuff, it's pretty easy. You can buy off-the-shelf hardware. You'll be able to get this presentation. There is a whole bunch of vendors out there. All you've got to look up is Whitebox. And you'll see Acton, EdgeCore, and they sell pizza-style boxes. And you can then download Danos, and away you go. It's pretty straightforward to do. So, but you have to spend a bit of money to buy the white box. You're looking at about, yeah, 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 yeah. EdgeCore is one of the more popular ones. Nicely built box.
What's the likely timeline for
Well, okay, good question. What's the likely timeline? It's available, I believe, now 701 is a Disag XR. And there are presentations on Disag XR from Akshat Sharma, who was the TME for the product. And I'm not sure if it's already happened or will happen, but you can certainly look at the recording, and they go through how to install it, how to run it, and it's out there. And it runs on particular white boxes. If I'm not mistaken, probably one white box has been certified for, but knock yourself out if you want to try it on a different one. But it's coming. What's coming in the future is completely disagged XR, where you get an application that runs on top of the Linux platform. But what we have today is the XR has the Linux platform compiled into it and runs on a particular piece of white box.
That next step is what? How far away?
That's next step. Okay, sorry. That next step, I don't know. Probably 18 months. You'd have to ask the TMEs. That's sort of, it's always dangerous to give you numbers. But I know they're working on that. It took them that long to get to this point. So, and again, it's customer requirements. We can't ignore what the customer wants. And so the initial time to market was to get this sort of compiled system out first and then go to that modular system in the future. Yeah. Any more questions? Yeah.
Where do you see the use of Disag in enterprise?
Yeah. I probably see it in large data centers more so than a network. And as I said, some large banks are really interested in it, really large banks, for their branches, because they've got thousands of branches and they're looking at sort of cheap boxes to do things. And that's where I've seen it, but I haven't seen it in any, like companies like Siemens maybe have shown interest in Europe because they've got, you know, process control and industrial control. They have huge factories, but not really. It's not really an enterprise thing. But having said that, you know, you see a lot of enterprises that look like service providers. From my days back in MPLS, where we thought MPLS was a service provider technology, and all of a sudden Citibank and a lot of others started putting these giant MPLS networks that look like service providers. So we call them enter providers, because everything that the service provider did, the enterprise did. So we will see probably Disag in the really large enterprises, but as I said, the only ones we've seen in the financial services world. Anything else? No? Well, you can always get to WebEx and ask questions, but thank you for your time. I do appreciate you if you turned up. It is still early. It's only 9 a.m. We can all have a drink, and I hope you have a good day. Thank you. Thank you.